Let me just ask you a serious question. Have you ever written a Python code and it felt slow? Like, bro, I just asked you to add numbers. Why are you thinking so hard? Well, meet NumPy, the library that turns Python from a bicycle into a Formula One car. And today we will learn what NumPy is, why it's insanely fast, arrays, vectorization, and broadcasting, and why Pandas, AI, ML, and data science literally depends on it. So if Python had muscles, NumPy would be the gym. Okay, so first of all, what is NumPy and why it exists? So NumPy stands for Numerical Python. It's a library built specifically for fast math, large data sets, scientific and analytical computing. And here's the truth. So Python lists are flexible, but flexibility comes with a cost, which is speed. Whereas NumPy arrays, so they are fixed type, stored continuously in memory, optimized in C under the hood. So what is the translation? So here Python thinks and NumPy acts. Okay, so let's just compare between the Python list versus NumPy array. And for the comparison, we have to just jump into a VS Code and do some coding there. Okay, so we are in our VS Code and we have a variable here which is number, and I am creating a list over there which is 1, 2, 3, 4, 5, and I am multiplying it by 2. So what do you expect? 2, 4, 6, 8, 10? No, this is what we get here. So in the list, we have 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. So Python be like, you said multiplied, I multiplied the list. So this is what we get from the Python list. Now, NumPy array. Okay, so for NumPy array, first of all, we have to import NumPy. So we have to write import NumPy as NP, and let's just create a variable here. So ARR equals to, now what we have to do is we have to create an array with a function of NumPy. So let's just quickly get the function from the NumPy, which is array. So np dot array, and inside the function we are passing the argument which is a list. So in the list we have the numbers 1, 2, 3, 4, 5. And now when I am multiplying it by 2 and run the Python code, we will get 2, 4, 6, 8, 10. So this is something that we wanted. That's why NumPy understand maths, but Python list understand the vibes only. Why is NumPy so fast? So there are three reasons. The first one is continuous memory. The second one is same data type, and the third one is written in C. So if we talk about the Python loop, then we get one element at a time. But when we talk about the NumPy operation, then we get all elements at once. And this is the concept that is called vectorization. Now let's understand the vectorization in more detail. So vectorization means no loops, one operation, and massive speed. Now let's check it with some example here. So here is an example where we are using without NumPy, which is slow somewhere. So we have a code here, result equals to empty list. For I in range of 5, we are appending the elements in that particular list. So we have result dot append ARR I multiplied by 2. Now this is the particular result that we are getting from directly with the help of NumPy, which is ARR star 2 or multiplied by 2. So with the help of NumPy, we have to less code, we have a less headache, but more performance. And that's why data analysts love NumPy. ML model run fast and your code looks clean and professional. Now, another keyword which is broadcasting. So broadcasting is something like a magic trick. So what does broadcasting mean? So the first one is NumPy adjust shapes automatically. So math still work. And this is where the broadcasting keyword comes. So let me just show you an example here. So we have an array variable equals to np.array, and inside that we have the value 10, 20, 30. And when I am adding 5 to that particular array, it is giving me 15, 25, and 35. So how did NumPy know to add 5 to each element? Because NumPy is smart and it broadcasts the value. It's like saying, hey, 5, go stand next to everyone. So this is heavily used in normalization, feature scaling, and ML pre-processing. Now, here is the time for the real practical example. So let's say you have exam scores. So we have scores equals to np.array, and we have the scores here 60, 70, 80, 90. Now, there is a bonus point. So bonus equals to 5. And now we have to add this bonus in your every exam score. So we have a final score equals to scores plus bonus. And when we print this, we got 65, 75, 85, and 95. With no loop, no drama, just clean math. Imagine doing this for 1 million record in machine learning, in financial analysis. And this is why NumPy exists. So, today you learned what NumPy is, why it's faster than Python list, arrays, vectorization, and broadcasting, and how real data professionals think. So, this is not just a library, this is the foundation of data science. And in the next video, we will go deeper into NumPy indexing, slicing, mathematical operations. And that's where you truly level up. So just hit the like button, subscribe the channel, and comment NumPy power if you are ready. We will see you in the next video. Till then, goodbye. Happy coding.